Hi. This is the second video in a series about the basic functionality of Enve, new open-source 2D animation software for Linux. Today I'm going to cover the general idea behind Enve effects. There are two types of effects in Enve, raster effects, and path effects. Raster effects are supported by all objects, paths, images, videos, drawings, layers, etc. We can add effects to the selected object through a context menu. Let's add the blur effect to the image. The effect has been added to the object. We can change the blur radius and animate it. Every effect can be disabled or enabled by clicking on the eye icon. Raster effects can be individually assigned to CPU, GPU, or both, but the supported processing options may differ between effects. For maximum flexibility, Enve allows users to create their own raster effects using the Enve core library. To use custom raster effects, we have to put them in Enve directory, located in the home folder. I prepared an e-shadow effect to serve as an example. First, let's quickly look at the code. The first few functions are responsible for creating and identifying the effect. Unsurprisingly, the e-shadow is a subclass of the custom raster effect class, for which we provide the effect's name and supported hardware. In the e-shadow constructor, we initialize and add all the properties we want the effect to have. The e-shadow has a blur radius, an opacity, a color, and a translation. Below, we have a function responsible for gathering all property values at a given frame, and passing them to a newly created object that will apply the effect. The effect applier has two separate implementations, one for GPU processing, and the other for tiled CPU processing. Let's move the e-shadow file, so that we can use it. Enve loads newly added effects at runtime, there is no need to restart. The e-shadow effect appeared in the context menu, let's add it to the image. The effect has all the properties we've seen defined inside the code. The blur radius, the translation, the color, and the opacity. Custom C++ based raster effects give a lot of flexibility, but they require a fair amount of code, and you have to compile them. For simple effects, Enve offers a much more convenient solution. Shader effects don't have to be compiled, and they are easy to create. Two files are needed to create a shader effect. First, an XML-based GRE file that defines all the properties we want our effect to have. Our example effect is called explode. It has three properties. A displacement property, of type float, will not be passed to the fragment shader, is influenced by the resolution, has the minimum value of 0, the maximum value of 999, the preferred value increment of 1, and the initial value of 10. A steps property, of type int, will be passed to the fragment shader. A directions property, of type int, that will also be passed to the fragment shader. Then we have a value named displacement xy, of GLSL type VEC2, that will be passed to the fragment shader, and has a value of displacement, divided by text size, an Enve-defined value, that corresponds to the size of the texture we are drawing to. Lastly, we have a margin with a value equal to the displacement. The margin tells Enve how much bigger the texture has to be to fit the effect. The other file is just a regular OpenGL fragment shader. The texture and texture coordinates are provided by Enve. Then there are values we defined in our GRE file. Steps. Directions. Displacement xy. The rest of the file is just a plain old GLSL. Let's move the effect and see what it does. We can edit the fragment shader at runtime. Enve will apply changes after we save the file. That would be it for raster effects. Now let's briefly talk about path effects, which influence shapes rather than pixels. They can be applied to all sorts of paths, node-based paths, circles, rectangles, and text. Path effects can be assigned to base paths, fill paths, outline base paths, or outline paths. As it is the case with raster effects, Enve also supports custom path effects. I'm going to show the example linearize effect. The code for path effects is structured similarly to that of raster effects. We have the functions responsible for creating and identifying the effect. We have the subclass of the custom path effect class, which initializes its properties in the constructor. In this case, we only have a single property called influence. Then we have the class that applies the effect based on the property values for a given frame. The apply function accepts only one argument, the path that it has to change. We are done looking at the code, let's move the effect to the appropriate folder, and see what it does. The effect does exactly what one could expect from an E-linearize effect. There's one last topic I would like to cover, and that is applying effects to groups. We can group selected objects by pressing Ctrl G. If we add a raster effect to the resulting group object, nothing happens. To use raster effects with groups, we have to turn them into layers. Now the effect is visible. Path effects are supported by both groups and layers, and they are applied to all contained paths. That's it for this video. Thank you for watching.